some of the important products of some of the condensation polymers which are important. Okay, the condensation polymers we are important. Already we know about nylon, but then now let us see about terylene. Terylene is made from ethylene glycol. Ethylene glycol, this is ethylene glycol. And terephthalic acid. Terephthalic acid is benzene, let us write the terephthalic acid. Benzene dicarboxylic acid. So ethylene glycol and this thing, they lose a water molecule and we get, this is n times, n of this plus n of that gives n times OCH2, CH2O, CH2O, C double bond O, so this is a terylene or dacron. This is terylene or dacron. So that is the condensation, first condensation polymer. Okay. So you know terylene or this thing are used in making fabrics. They are a replacement for cotton. So we have a lot of synthetic fabrics like terylene, this thing. So by using it, we are making a lot of clothes. Okay. So other thing is nylon 6,6, you know very well, is obtained from hexamethylene diamine. Hexamethylene diamine and adipic acid, which we have already seen. Hexamethylene diamine and adipic acid. So this is nylon 6,6. This is all this put together. They lose a thing. We know about how the formation it is. We have already seen. So this is used for making sheets. And there is a nylon 6. Is a nylon 6. Nylon 6 is made from caprolactam. Caprolactam is nothing but C double bond O I will write it like this. It is a cyclic structure involving a C double bond O and then NH. Other things are CH2, 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 1, 2, 3, CH2, CH2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, C double bond O. So this is caprolactam. Okay, from caprolactam we are able to get nylon 6. Nylon 6 is the n times of caprolactam. Okay, so this we are able to get C double bond O, CH2 5 times, NH. This is nylon 6. This nylon 6 is used for making all ropes and other material. This is caprolactam and this is nylon 6. Okay, these are some of the important condensation polymers. Now let us see some of the important things of condensation polymers. One is this, other is the bakelite. Bakelite is from phenol and formaldehyde. So this bakelite is of a giant polymer. This is a giant polymer which is made up of phenol. Phenol, you know very well, is phenol and formaldehyde is HCHO. Okay, so phenol and formaldehyde, depending upon the number of CHOs which are getting added, so it can be first there is an addition, so this is one, or it can be CS2OH attached to the para portion, ortho and then para portion, or this can be so ortho and para, that is try in all the three positions you get the CS2OH attached. Okay. In case if you take a molecule of this type and if this undergoes the polymerization, n times of this undergoes a polymerization, you get then a condensation polymer like this. So like that it is getting repeated. Okay. So if this is of this type, then this is called the, yeah, you have a CS2 here also. So this is of the type called novolock. Many of these novolock gets attached, layers of novolock get attached to get, again this is treated with formaldehyde, more of formaldehyde. We get bakelite. Bakelite as a continuous representation of CS2 on all the sides. So there is of many this thing repeated units. This is called the bakelite. So many such repetitions of the same novolog in the for three-dimensional figure gives the bakelite. So you have a CS2 here, CS2 here, everywhere is the CS2. Of course, let us complete this also. Many such things they get repeated to get the bakelite. So bakelite is a giant polymer which is happens on further condensation. First the small condensation with one happens. The product which is formed is getting further added. So it is step growth. What we have said as step growth polymerization is happening here. And of course we have melamine polymer. So if you know melamine copolymer. This is another condensation. The things where so it is like a benzene like where it contains 6 nitrogen atoms with alternate NS2s. With alternate, this is called melamine. This melamine with the formaldehyde forms the melamine copolymer. So this will be like so this is the melamine copolymer. This is melamine on addition with the formaldehyde gives the melamine copolymer. Actually here since the CS2OH is getting added, we have to put a CS2 here. CS2O, this is so the CS2 is getting added here. So here also there will be a CS2, here also there will be a CS2. So this is the melamine copolymer where CH2, this is the CS2. So this is melamine. So melamine with the thing gives the melamine copolymer. This is N times, and this is all N times, and this is also N times. These are some of the important condensation polymers. We have first seen Dacron or Terylene and nylon 6,6 nylon, then bakelite plus melamine copolymer.